Welcome to a tutorial of Proflan. This particular video we're going to look at how you can be able to solve VEP merge of Cambridge IGCSE Physics, that is paper 4 of 062542. So we're going to see what are the basic concepts that you need to work on and how you're supposed to approach each of the questions. Now, number one, you need to understand that this is a paper that is a theory paper of 80 marks, and we're going to go through 7 questions. Now, the first question was testing the concept of motion graphs, and then you are supposed to identify what is represented by the flat section, that is from 0.9 all the way to 2.9, and this represents a constant speed because this is the speed time graph, so speed is constant from 0.9 to 2.9 minutes. We need also to describe the motion between 2.9 to 3.5, and this basically represents uniform deceleration. This section represents uniform deceleration, and this section from 3.5 to 4.5, that represents stationary or at rest. We need to also look at a section whereby you are supposed to work out the kinetic energy, and we are told that another bus travels at a speed of 8.9 meters per second, and the brakes applies a constant force, and the bus stops a distance of 23 meters. This bus has a mass of 18,000 kilograms. Work out kinetic energy. So the first thing that you need to realize here is that kinetic energy is given by the formula a half times mass times the speed squared. And if we substitute what we have, we are going to get our answer equivalent to 7.1 times 10 to the power 5 joules. So you need to move it here so that the examiner can be happy. We need to work out the force applied to stop the bus. Remember, all the kinetic energy, the force will be working against kinetic energy, and so work done is equal to the force times distance. And in that case, our work done is the kinetic energy the car was, or the bus was possessing. So if you can use 23, which was there, then we can be able to now make f the subject the formula. Working it out, we're going to get 31,000 Newton of force. How do you define impulse? Impulse is defined as the product of force, force and time. So in that case, you need to remember that impulse is also equal to the change in momentum. So if you have impulse, you divide that impulse ft, because we know impulse is equal to change in momentum, and the momentum is mv. So if we divide t both sides, we're going to have this formula, and we substitute to 800 and 1400 divided by 1, because we are talking of 1 second, and then that becomes 3920 kilonewtons. And we need to check the maximum force that can be lifted. We're going to use the formula force equals to ma, but a is going to be the gravity because the mass is going to be lifted upwards. So we're going to say maximum mass is force divided by gravitational field strength, and if you work out that, you're going to get 4.0 times 10 raised to power 5. Then 4.0 times 10 raised to power 5 kilograms. So remember to be including the units whenever you are working out questions in IGCSE Physics. In the event I ask you a question to do with pressure, you need to remember that pressure is force over area, and then you are supposed to substitute, and our pressure becomes 2.0 times 10 raised to power 5 pascals. And you need to remember that there are 4 tires, and each of them had an area of 0.016. So for us to find the area, you have to multiply by 4 so that you have everything there. Due to the friction force, explain in terms of particles why air pressure in the tire increases. Remember, as the car or the bus is moving along the road, temperature increases because of friction force between the tires and the road. And when temperature increases, kinetic energy of the particles will increase, and this is going to increase the rate of collision, the rate at which the particles collide with the walls of the tire, and this is going to increase the pressure inside the tire. A gas cylinder containing helium gas at a pressure of 2 times 10 raised to the power 6 pascals, a volume of 0.026. Compressed gas is released from the cylinder into the balloons, and each balloon contains 0.015 meters cubic of helium. The atmospheric pressure, which is 1.0 times 10 raised to the power 5 pascals. The temperature remains constant, so we're going to use the concept. Okay? So let's write force per unit area is pressure. Now we are going to use the formula here, P1 V1 equals to P2 V2, but we are going to put N because of the number of balloons that we are talking about. Then substituting the values that we are having here, we are going to make N the subject of the formula, and that becomes over 1 times 10 raised to the power 5 times 0.015, and then this becomes 34 balloons. Define specific heat capacity. Specific heat capacity can be defined as the amount of thermal energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. Right, so the next part here, we're supposed to calculate the density. Remember, density equals to mass or volume. Rather, we are finding the mass, but you are using the formula density equals to mass or volume, but mass can be rearranged so that we can have mass is equals to density times volume. So if we substitute here, we're going to get our answer as 2.2 kilograms. And to calculate the energy required, you are going to use the formula E equals to mc, change in theta. And in that case, is our mass is 2.18. Of course, I rounded off in the previous section, so times 2000 times 160, which is the temperature change, because you see the temperature was 20, it moved to 180, so temperature change was 160 degrees Celsius. So, and also work, in order to work out power, remember power is energy divided by time, and remember volume of oil was heated in a pan for 7 minutes, so we have to convert that to 7 times 60 so that we convert it to 60, and the energy we are going to use the previous one. Moving to question 5, and question 5 is from electromagnetic spectrum. Choose from the region the list in this list. Each region used more than once or not at all. Cancer treatment, we use gamma rays. Bluetooth, we use radio waves. Optical fiber, we use infrared. Security marking, we use ultraviolet. Sterilizing medical equipment, we use gamma rays, and wireless internet, we use microwaves. So those are the uses of the electromagnetic waves. But you need to also to remember that whenever you are doing the topic electromagnetic waves, you need also to remember the effect and harmful effect of these electromagnetic waves, because some of them may cause cancer, like X-rays and gamma rays. Infrared can cause skin burns, and ultraviolet can cause skin cancer. So you have to protect yourself by reducing exposure time, and also by putting on protective clothing. You need also to remember in this topic that common properties of all the electromagnetic waves is that all can be traveled at the speed of light, all can be reflected, refracted, and diffracted, and also they obey the wave equation F equals to F lambda. And you need also to understand the differences wavelength or frequency. All these waves, they differ in terms of frequency and wavelength, but they travel at the speed of light. This is a diffraction, and diffraction is a spreading of a wave around a boundary or a gap. And then this is the wave that was incident, so you can see the gap is almost the size of the wavelength, so the waves will be circular like that. And in the event if the gap is big, the waves will experience a very small amount of diffraction. Yeah, so sound undergoes diffraction. That's why you can be able to hear sound from a room, and if there is a gap there. Determine the focal length by drawing the ray on the figure. So the focal length, of course, first we need to remember that the first ray usually run from the top of the object to the top of the image like that. So where this line crosses the principal axis, that gives us where the lens is. So our lens is going to be at this given point. Yeah, so if we identify our lens here, there is another ray that usually runs parallel to the principal axis. Whenever it meets the lens, it goes back like that. So this point here is where we have the principal focus, and then the focal length is the distance between the F and the lens, and that is going to be approximately 2.2 centimeters here. This distance you are supposed to measure using a ruler, and then we were supposed to, the object is moved 2.0 centimeters closer to the lens. State 2 changes to the characteristics of the image, and in that case the image is inverted, and we can also talk of the image being magnified. Yeah, so yeah, so if you draw that image, you can see it will be extrapolated backwards, and that is going to be our image. So the image is formed by imaginary rays, so that's why we're saying it's inverted. All the image is virtual. Well done, and I wish you the best in your coming exam. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. We are moving to electricity. You are supposed to know how to draw the symbol of the potential divider, and the potential divider is drawn like that. That's what you're supposed to do. And then you remember the formula, V out is equals to R out over R out plus R times V in. So we are going to use that relation. Our V in is 6, and then this is going to be 1. V out is usually where you are removing the voltage. R out, you use the resistor where you are removing the voltage. So that's why we are going to say 1 over 1 plus 3 times 6, and that is going to be equals to 1.5. 1.5. Remember, charge is equals to current times time, and this is going to be 1.7 times 10 raised to power negative 3, because we were given milliamperes, and this is going to translate to times 300 seconds, and that's going to translate to 0.51 coulombs. So remember, when current passes through a conductor, magnetic fields are created around that conductor. And the pattern of the magnetic field is going to be as follows. So since this current is going into the page, the magnetic field will be circular, concentric like that. But you are going to use right-hand grip rule such that the thumb is pointing into the paper, so the other fingers will indicate the direction the field. Now we are supposed to, the current, the wire increased, the direction of the current is reversed. The current is reversed. The magnetic field will be closer, and the direction of the magnetic field will change. Now the current in the wire increases and the direction of the current is reversed. So what's going to happen here? The magnetic field will be closer, so meaning since the current is stronger, then it means that the field will be strong, so they will be very close, and since the current is reversed, we are going to have a current that is flowing in the opposite direction, so the field will also point in the opposite direction. So you need to add a statement there. The fields will be closer and also they will be pointing the opposite reversed direction. Now we need to move to the other part. Electricity is transmitted at high voltage. Explain why high voltage increases efficiency. Remember, high voltage reduces the current and this minimizes power loss. And even the pylons that can be used when we're having high voltage will be, you can even use thin wires because current will be less, and this will be preventing power loss. And remember, power dissipation is usually P equals to I squared R, like that. Good, so that is electricity for us. We need to move to radioactivity and also particle model of an atom. And in this case, we are told that in an experiment directs alpha particles at a very thin of gold foil. Most of the alpha particles passes through the thin foil in the straight line. See the conclusion about atoms from this observation. So most of the alpha particles passes through, so meaning that the atom is kind of having much of the space empty. So alpha particle pass through in a straight line, most of them, so meaning they did not interact, they did not collide with anything. So in such kind of observation, you say most of the atoms in the atom is actually much of the space, most of the atom is empty space. And we are going to have some of the alpha particles deflected through angles of 90 degrees. A few are deflected at 180. So if some of the alpha are deflected at 90 degrees and others at 180, so we're going to say the nucleus is very small. Yeah, so the nucleus is small, so many alpha particles pass close to the nucleus. So here the first conclusion, we say the nucleus is very small and is centrally placed, and so not many alpha particles passes close to the nucleus. Not many alpha particles passes close to the nucleus. We also have the second close to the nucleus. So conclusion 2, we are going to say the nucleus is positively charged, so that is why they are repelled away. So the nucleus is positively charged, so the alpha particles which are positively charged will experience a repulsive force. State the change of the nucleus occurs when alpha particle is emitted. In this case, a neutron is changed or converted into a proton. Alright, so the initial mass of isotope strontium is 225 micrograms. Calculate the mass of strontium isotope after 87 years. So we need to understand the half-life is 29 years. 87, how many half-lives do we have? Those are 3 half-lives. So this is going to decay 3 times. It will decay once and then last it will decay. So the mass that will be remaining is 3.125 kilograms. So mass that has decayed will be 25, which was the original, minus that, and that's going to translate to 1.875. 1.87. We are told that the figure represents different positions. A to H of moon as it rotates around the earth. So we are supposed to show a quarter moon. The quarter moons will either be at point A and point B. Full moon will be at point G. We shall have a full moon, and the approximate time for the moon to orbit the earth is actually 1 month, which is approximately 30 days or 28 days. So you need to mention that during the exam. You need to remember that. Now another concept that you need to remember is the concept of orbital speed, and orbital speed is actually distance around the orbit divided by the period. Period is the time taken for the object to move around a given orbit. And then we shall write the formula in that case and substitute everything that we have here. We are going to have our answer equivalent to 107,589. 107,589, like that. Speed of light in a vacuum is 3 times 10 raised to the power 8. Calculate the time taken for light from the sun to reach the earth. So we need to use the distance divided by speed formula, and that will give us the time, so that we can be able to get that. So if you substitute everything that we have, the distance from the sun to the earth is basically given here. Average distance is 1.5 times 10 raised to power 8 kilometers. So we have to convert that to meters by multiply by 1,000, then divide by the speed, and the distance, the time taken is actually what, 500 seconds. 500 seconds. So from also space physics, you are going to say the condition required for a protostar, and the condition required for a protostar to become a stable star. Remember, a protostar becomes stable when the inward and the outward forces are balanced. Inward gravitational force and the outward force due to high temperature and pressure is going to okay, for number 11a, you have to write inward gravitational force balances with outward force due to fusion reactions. We are supposed also to know how to define Hubble's constant, and Hubble's constant, we are going to say, is a ratio of the speed at which a galaxy is moving away from the observer to its distance from the observer. So we are going to say that is the Hubble's constant is actually h over v over d, where h is Hubble's constant, v is the speed at which the galaxy is moving away, and d is the distance between the galaxy and the observer. Yes, now you are making noise. Can you stop that? Let me just finish, then we continue. Stop making noise. Look at this. Let's finish this. No, stop making noise. All right, so we need to move ahead, and this is the formula for Hubble's constant. Now the current estimate for Hubble's constant is 2.2 times 10 raised to power 10 raised to power negative 18 per second. State the equation which gives the estimate for that. So we are going to estimate for age of the universe. So age of the universe is usually Hubble's constant, 1 over Hubble's constant, and we can be able to now do that. Then we are going to get age of the universe in seconds to be equivalent to 4.5 times 10 raised to power 17 power 17. Guys, there's a guy who's disturbing me here. No, let me just finish. Okay. All right, thank you for watching Proflan YouTube channel. We've come to the end of this tutorial. If you've not subscribed, consider subscribing so that we can be able to be notified when we shall upload the next tutorial. See you in the next video.